I'm fine. I'm fine. I'm getting ready to take my first trip to Israel. I'm looking forward to that.
Wow, really?
He has an aging meeting, and I've never been there before, so it sounded like a great opportunity.
Oh, how fantastic. How fantastic. Well, so are there particular people there that you're excited about, or is just the idea of being in Israel?
Yeah. It's a lot of people. Well, I'll meet a lot of new people, but I'll also be there with a lot of people that I work with already. In fact, the guy that invited me is the former chief medical officer of the Israeli army. So he's going to take me around for the first few days that we're there, because I'm learning what a small place it is. It's just incredible. You go from one side of the country to the other in 30 minutes.
Wow. Well, let me tell you, I think you're going to enjoy when you get the final piece of this to listen to.
Okay.
Part of this program called Impossible Fossil, and where I see how that's used in biology is the idea of really promoting to people that they can be an impossible fossil, and I think that you are Exhibit A.
Mm-hmm.
So let me do one thing here. I just realized. Bear with me. Just before we start, I'm going to try to close out some stuff, which I thought I already did. Word, and then we get. There we go. So here's what I want to do is I'm really going to work with the idea that we're just going to enter into conversation, and I'm going to pick this up at some place. So we've already been talking. I'll do an introduction.
Okay.
But I've been curious. I've heard all of the mythology around your life, and and there's that. It's the thing I wanted to understand. If you've been asked, or what was it like when you were growing up? Did you sense when you were growing up that you had a sense of curiosity?
Oh yeah, I always had a curiosity about nature. I never thought I would go into studying nature professionally. I always thought I was going to be a mathematician. And the reason is I was good at math and people just pushed me in that direction. But I remember my high school biology teacher telling me, "You're going to be a biologist."
Wow, really?
And I said, no, I'm going to be a mathematician. So it turns out he was right, of course.
So what kind of work did your mom and dad do?
So my dad was a newspaper pressman, and I had a really unusual childhood in that he got a kind of wanderlust. And we bought one of these small silver bullet house trailers and hooked it up to the car and drove around the country for about 5 years, living 3 months here, 4 months there. So I went to over 20 grade schools, many of which I have vaguest memory of.
And so did he work as a pressman at different newspapers?
Yeah, he was in a real strong union, and they could get something called a traveling card, which if he showed up at a big city newspaper, they would have to put him on for 3 months or something. And so that's what we did. And it was really unusual. It struck me as perfectly natural at the time. I remember being a little bit upset when we first left Long Beach, California, which is where I was born, because I had my friends there and everything. But then after a few months, it was just like, oh yes, and we're going to be in a new place 3 months from now, and I'm going to meet new people.
And how many brothers and sisters did you?
I've no brothers and sisters.
Oh, okay.
That probably made it possible because the three of us could live reasonably in this little tiny house trailer. My parents had a bedroom in the back, and I slept on this fold-out couch in the front. So,
wow. So your mom must have liked this as well.
I never really questioned them about the dynamics. She was a housewife for much of her life. When she wasn't, she was a waitress. And so I remember her getting jobs here and there, but nothing very long. But I don't understand my parents' dynamic through all of this, because it can't have been, they were both, she had lived in Long Beach, California since she was 3 years old. And my dad had lived there since he was a young boy. So this was a huge thing. Although my dad, when he grew up, his family were migrant farm workers.
Oh.
So I'm wondering if that was sort of in his blood from growing up, following the crops, from California up to Oregon and Washington and over to Idaho, Montana, and then back down through Nevada and California again.
So how long did this traveling last? Where you went to high school, or did you continue?
Yeah, no, it stopped when I was in 8th grade. Just before I went to high school, we stopped in Portland, Oregon. And I went to the last year of middle school and started high school there. But then we moved again in the middle of high school because his union went out on strike, and they ended up getting their union broken. So my dad we wanted to stay there. We loved Portland, but he tried to make it as a longshoreman. But he was, he was sort of a small intellectual guy, not cut out to be a longshoreman at all. He ended up dropping something on his foot and breaking his foot in a gazillion places. So then we moved back to California. Right where I started off, I ended up going to the same high school my mother did.
Right. And then you went to, where did you go to school after that?
Then I went to UCLA. So it wasn't that far. I wasn't consciously trying to stay close to home, but I just liked UCLA because it had so many options. And even though I went there as a math major, I wasn't entirely certain I was going to stick with it. So after about a year and a half, I switched to English literature. And that's actually what my degree is in English literature.
Mm-hmm. But it was a rich period of time that you were there. I mean,
I was there in the late 60s, and
things were popping. That was the heart of the world.
Yeah. No, it was very, very exciting. In fact, what happened was I got involved in a lot of anti-war stuff, and I broke up with a girlfriend. I ended up dropping out of college with 1 quarter left to get my degree. And I'm the first person in my family that ever went to college. And I hitchhiked around the U.S. for, a year. And that was it. My parents must have thought, that's it. The kid's never going to get a degree. We're never going to have a college graduate in the family.
What did we do to him in that traveling all over everywhere? How did we do this? Yeah.
Well, I was a very good pool player. So I actually made some money playing pool. It was during the height of the anti-war activism. It turned out that I showed up in New York City right at the time of the Columbia riots. And I met a girl who was involved politically there. So I was right in the middle of the Columbia riots, occupying the president's office, drinking his brandy, all that stuff. And they must have wondered where I came from, because I wasn't, they were heavily infiltrated by government spies, as it turns out. But it was just a really exciting time, I have to say. Then I went off to Europe and hitchhiked around Europe with this girl for a year. She got arrested in that riot, and I didn't, because I always knew when to get out. So I got out before the police. We occupied these buildings for 5 days, and I got out just before the police showed up. So.
And then you worked as a taxi cab driver, which is cab.
Yeah. When we came back, I got a job driving a taxi cab, and then we moved to Portland together, and we hitchhiked. Actually, we hitchhiked from New York City to see my parents in Southern California, and then up to Portland, Oregon, because I still liked Portland. I remembered it from when I lived there as a kid, and I got a job working for a newspaper there. She got a variety of jobs there. And it's funny because she was at the top of her class in the Oriental philosophy department at Columbia. Wow. And she ended up working as, she made Christmas tree ornaments. She just had a variety. She spoke fluent Chinese. Even though she was Irish.
So did you work as a writer at the newspaper?
Yeah. And a copy editor. I got this job because they gave me the spelling test. It was like 500 spelling words, and I'm a good speller. So I got hired on that, and the fact that I had an English degree and I liked to write.
And then what transitioned in terms
Well, what happened was, at the time, I was taking karate lessons, and my karate instructor had a couple of African lions for pets because he's nuts. And I didn't realize that at the time. And so he got an offer to use his lions in a movie in Southern California, and he needed somebody to help him transport them down there. So he asked me to do this, and we had a incredible series of adventures on the way, but eventually we got down there. And the movie producer offered me a job, and it was only supposed to last 3 months. And I thought, well, I'll just take a leave from the newspaper.
And what was your job? What were you doing?
I was training the lions.
Oh, okay.
But I didn't have any experience in it. So when he offered me the job, I said, you know I just drove 1,000 miles with this lion in the back of this car, but I really don't have any experience with this. He goes, that's okay. I've hired some experienced trainers, and you can learn from them. So don't worry about it. So that was supposed to last 3 months, but it was all for one movie that required 20-some lions all working together. But he had trouble getting financing, so he ended up buying all these animals. We had 55 lions and a dozen tigers. And while he was trying to get his financing together, we used them for movies, commercials, public events. And so that's what I did for 3.5 years.
And then you found your way to work with a bear?
Yeah, Well, eventually I had a falling out with this guy, but there's an area of Southern California where all the wild animal that are used in movies, they all tend to be in this one area because you can have them there. And so one of the neighbors who I'd made friends with was also an animal trainer. So he offered me a job working with him, and he had the bear that was Gentle Ben in the TV series. So I did some stuff with him. I did a movie opening, I remember, where I went to the movies with the bear, and with television cameras following us around, and I sat in a chair next to a bear and put my arm around the bear and pretended to watch the movie together.
Tell me, how do you work with a lion and a bear? I mean, how do you sort of gain their sense of calm?
Very differently, actually. With a lion, you really have to be number one lion. And so you have to fool them into thinking that you're the dominant one. And if they ever figure out that you're not, then you can't work with that lion anymore. So I got reasonably badly injured by a lion one time. And when I came back to work, we tried to see if I was going to be able to work with that one again. And no way.
That's that guy I took out. He's not going to do anything with me.
Yeah, that's right. So he was fine until I wanted him to do one thing and he wanted to do another. And then he just came right after me again. But we were prepared for that. So, I mean, we had it set up so he couldn't reach me. But
so you got bit? You got somehow...
Yeah, I got mauled. I got dragged around.
Wow.
Yeah.
That didn't stop you. You went on to bears.
I did, but I think I was thinking about getting out of the business after that. Because I started taking some classes at Cal State Northridge, which is the closest university, in biology, because I thought I've got all this sort of applied knowledge about animal behavior. Maybe I could study this in a more formal fashion. So while I was still working with the animals, I was taking classes, ended up getting a degree in biology. I was only trying to get enough classes to get into graduate school, and kind of by accident, I qualified to get a biology degree.
So tell me about the difference on the bear. I've got to know that one thing.
Okay, so the bear you can't bully. A lion you can bully because you're number one, and you have to stay number one. A bear, you can't do that. A bear, you have to work with reward. So with the lion, you never, ever wanted food around when you were around the lion, because they get possessive about food. With the bear, you want rewards, and you want to give them little treats all the time. So they love these little Tootsie Rolls. So I would carry around lots and lots of these Tootsie Rolls and be giving the bear Tootsie Rolls all the time. The other thing is that makes them really different is that because they're social, lions have a lot of facial expressions and body postures. They're kind of like dogs.
Wow.
If you know dog behavior, you can kind of tell what they're thinking and what they're likely to do. Bears are more like tigers. They don't have any facial expressions, really. They can be getting madder and madder and madder, and you can't really tell till they suddenly just lose it.
Yeah.
And so that was a lot harder really for me to do.
And so then so then you went and you started taking classes in biology.
Yeah. And then when I had enough classes to go to graduate school, I started applying to graduate programs, and I really wanted to study lions in the wild. That was the whole reason I went to graduate school, is I thought, I know all about lions in captivity. I want to find out what they're up to in the wild. So there's been a long-term project on the Serengeti of lions since the 1960s. And I went to graduate school because my professor had all this experience in East Africa and knew all the people. So there was a break in this Serengeti lion project. The people had been doing it left, and there was nobody to take it over. So I hopped on a plane and I went over to Tanzania. And it turns out that in the time between my professor getting back and me getting over there, some people had showed up that had a lot of East Africa experience, had grant money, and they took over the project even before I got there. And so that didn't work out. So, I had to...
And then when was the, obviously I'm going to ask you this thing, is like, when was the sort of turn to where you got into or interested in aging?
That was as a postdoc, believe it or not. So I ended up using my sort of math skills. I did a PhD on some highly technical game theory modeling of animal combat, because I was still interested in animals fighting. But then I was working on a postdoc, and I was in South America working on some social birds, and a friend of mine was trying to study foxes there, a friend from the Smithsonian, and he wasn't having any luck. He was just catching all these opossums in his traps rather than foxes. So I said, well, you idiot, you're studying the wrong thing. You should be studying the opossums, because at least you can catch them. And he said, well, what can we do with them? And so we ended up writing a grant, and we got the grant funded. It had nothing to do with aging, but to do that research, we put radio collars on these animals, and then I would recapture them every month and sort of check them out. And when I did that, I realized that they were aging incredibly fast.
Because this is I saw that in your book, Why We Age, there's Methuselah opossum or...
Well, no, these are really short-lived. I mean, they don't live any longer than a mouse, really.
Oh, okay.
And I got and it wasn't just that they died or got killed, but I'd catch them and they'd be in fine shape, and I'd catch them 3 months later. They'd have cataracts and arthritis and just look awful. So that's really what awoke my interest in aging, was that, thinking, wow, I would have thought an opossum would age kind of like a house cat. They're about the same size and all. And
then what did you discover what accelerated that aging?
Well, I don't know. I mean, this is really what happened. About that time, I got a faculty position at Harvard. And so I didn't want to continue working in South America. So I found this opossum project that was off the coast of Georgia and in South Carolina. And there was a prediction from this evolutionary theory of aging that animals that have been evolving in safe environments should age more slowly, should develop better protective mechanisms, a better immune system, better heart. And so I did this field experiment where I compared aging on the island and the mainland and found out they were different. But then I was kind of stuck, because this was in the early 90s. What I really wanted to know was, okay, what happened? What change occurred when these opossums moved out onto this island? How did their genetics change so that they're now aging more slowly? But there weren't any opossum genetics at the time. So I was really stuck. So I moved on to other things. But now I'm hooked on aging, because it's such a neat, interesting puzzle that I really couldn't give it up at that point. So then I tried to replicate the same thing in using mice, because in mice we had all the genetics. So if I could find the same thing, we could figure out the genetic basis of it. So I actually went all over the world trapping wild mice on islands, hoping to find exactly what I'd found in opossums. So
when was that first discovery or aha moment for you?
Well, in aging research, stuff doesn't happen overnight.
Right.
So I studied these opossums, a group of them, from the time they basically emerged from their mother's pouch until the time they died. So that took about 3 years. So it was only towards the end of that study that I thought, I was right. These guys really are aging more slowly on the island. So it sort of gradually dawned on me that, and I knew the island had been separated from the mainland for about 5,000 years. So it gradually dawned on me that I've discovered something really, really interesting here, which is a single species can change its aging rate fairly quickly because of natural conditions. And that work is still, it's really kind of become a classic in the aging field. Most of the people that I know in aging now don't even know that I'm the one that did that study necessarily.
So it almost sounds like stress accelerated your.
Well, I don't know. It could have been stress. The big difference between the island and the mainland is on the island there weren't any predators. Right. And on the mainland, possums, 80% of them are killed by predators. Mm-hmm. So part of it may have been stress, but I think it was mainly some sort of genetic change that happened.
I see. Because
they looked a little different. They were a little bit smaller. They had smaller litters on the mainland. On the island. So they were different in variety, just behaviorally. The first one I found, it was just on the island. It was just laying in the middle of the path. On mainland opossums, they hide. They have nests in trees or holes underground or something. This one's just laying on the ground right out in the middle of nowhere. And I think, this island doesn't have any predators. Of course, why would it bother to hide? There's no reason to hide. And I walked right up to it and grabbed it, picked it up. So,
what is it like? I was wondering because I the idea of working on a project, and is it kind of solitary sometimes? And it's like I'm trying to understand that point in which you decide, I'm going to share this with somebody.
Yeah, no, I've spent a lot of time on that project by myself. I had a little tiny house trailer. Here I was back in a house trailer. This one was even smaller that I lived in there while I was doing it. And basically, it was me and my radio tracking gear and the opossums. The island I was working on, half of it was a nature reserve. And so the other nice thing about it was that people weren't going to bother with what you were doing up there. So I would just spend, and I was following these things at night. So I was spending nights tromping through the swamps and the brambles and everything. Eventually I got some field assistants to help me. But for the first year, it was just me.
So it can be a pretty solitary existence.
Oh yeah, it was. When I was working in Venezuela, I was at a biological field station. So there's tons of other biologists around. And every night, you talk about what you did that day. This place, there was a marine station there, but it was a ways away. And I was typically too tired to go schmooze with people at the marine station anyway.
Was there somebody early in your career that kind of inspired you, that either was an age scientist or that you found that they advised you or made it helped you see a discovery of how to work better? Or
well, my PhD advisor was really a good advisor for me. I don't think he would have been so great for everybody, but what he was so good at was just asking me questions. Oh, why are you doing that? What do you think you're discovering? And it was really kind of disconcerting because he would listen very carefully to your answer. And if somebody listens and doesn't say anything and you go on and on and on, eventually you start saying stuff that's stupid, So I'd be talking to him and I go, God, am I making any sense at all? But he was very, very good. And I guess he encouraged me to just follow my interests.
Right.
And, now that I'm in this kind of medical field, most of my colleagues, when they get a graduate student in, they get it to because they want them to work on this particular issue that they've put in their grant proposal. I didn't have anything like that. I was completely on my own to pick my project and follow it whatever direction I wanted to. And he would just give me advice on how to proceed. So nobody.
You can kind of hear his voice when are you working on a project? Do you ever have those moments that you've embedded it into your process?
No, I never did. But what I've often thought was, I wish I could listen as patiently as he could. He was really so good at that. And it was weird because I'd had this interlude where I was the reporter and the lion trainer and all this stuff. I was almost the same age as my graduate mentor. He was, a year or so older than me. So I was a pretty atypical graduate student. I guess I really can't think of any people that I considered to be role models.
Right, but what I'm saying is, so there was some sort of protocol in you doing your work now that what am I doing? Where's this going?
Yeah, well, I think this is what the solitude actually was really good for, because you could just spend hour after hour after hour thinking exactly about, what does it all mean? Where am I going? I've always been reasonably adventurous, and one of the most adventurous things I did was take off in this completely different direction. Here I was with training in field behavior, and suddenly I was going to study aging, which I knew nothing at all about. So it was nice that I was at Harvard at the time, because if you're a junior professor at Harvard, they don't care what you do. They absolutely don't care. Do what you want. It's up to you. You can sink or swim, but it's completely on your own. So it really was a period of about 3 years that I could completely retool the way I thought and what was going on in my laboratory to shift over from a kind of behavior to aging.
Well, it's interesting because looking at your writing, and even the articles in the San Antonio newspaper and so on, your observant kinds of qualities about behavior, and also, I guess the biological studies that you do, it brings to, if we bring it up, today, to understand the questions that you hear most about aging, and I want to get on that in a minute, but I want to leap forward and ask you about this, because I think it has to be articulated in its most present way, and that is aging as a disease.
Yeah.
And I'd like you to talk about that, because when I talk to people about that, they go, "What? Aging is a disease?"
Yeah. Well, so I have this funny idea. In the aging field, we spend a lot of time arguing about definitions. Even you can't get 5 aging researchers to agree on what you mean by aging even. My attitude about that, and aging as a disease comes in here, is I'll accept whatever definition you want to give me if we can both learn something from it, right? And so aging...
Hello. Hold on one second. Alexa, stop. Sorry.
That's okay. Aging, I don't really think of as a disease, but I see it just because it's something that happens to everybody. And to me, if something happens to everybody, it doesn't make any sense to call it a disease. But if people want to call it a disease, on the other hand, I have no problem with that if it's useful. And I think it is useful because it gets the medical community to pay attention to it in a way that they won't if you don't call it a disease. So from that perspective, I say, fair enough. Let's call it a disease. If it gets more attention and it's going to lead to more research, then I'll call it. Yeah, I'll call it anything. I'll call it dessert if you want. So I think that's pretty useful, because if you want to get big pharma interested in aging, if you want the FDA to approve drugs potentially to slow aging, they need to think of it as a disease because that's the business they're in. You know, they're in the disease business, not in the...
What I'd like you to ask you about is that I heard, I need to understand the idea that if we were able to put money into aging research, then the ideas as you get older, you're more susceptible to cancer, diabetes, Parkinson's, dementia, Alzheimer's. And that kind of connection and how that presently is being explained about being able to solve those problems.
Right. So one of the advantages, I think, of thinking about aging, not as a disease, but as an underlying process, is that it allows you to see how it's involved in basically almost every health problem we have. I'm calling it the number one threat to human health that we have. And that's because it's the underlying factor for Alzheimer's disease. It's the main underlying factor for cancer and for heart disease and for osteoporosis and muscle wasting. And what's happened in the early 21st century is that people who study heart disease and people who study cancer and people who study Alzheimer's disease are suddenly realizing, you know, there's a lot of similarities in the underlying processes that are going on in these diseases. And those of us in the aging field are going, well, duh, you know, it's aging. That's what's going on. And we're gradually losing our ability to resist, you know, the forces that want to weaken and kill us. And if we can figure out a way to address those underlying forces, then it's going to help protect us against all these things at the same time.
So if I understand it, explain this to me. When I talk about when we're getting older and our cells go into senescence, when that word senescence, and that means that the cells begin to not work properly, or they start to shift and change?
Sure. So that has a pretty technical meaning. Now, I don't like the term anti-aging because it's just been co-opted by a lot of charlatans, as far as I'm concerned. Senescence to me is actually a more precise word for aging. It just means not just change over the passage of time, but deterioration. Sure. But in terms of cells, it's got a pretty precise meaning, because the first person to discover the fact that cells changed in predictable ways the more times they divided called it cell senescence, because he thought it was a model for what went on in your entire body, but it was in a cell. And so now cell senescence has a fairly precise meaning. And the meaning is that cells are no longer capable of dividing anymore. But instead of that, but they don't die, they persist, but they start secreting a lot of stuff that's bad. And so suddenly they become toxic. It's not like they just died. You'd love it if you had a cell that lost its ability to do what it's supposed to do. If you had a liver cell that didn't behave like a liver cell anymore, it'd be great if it just died. But it doesn't. It just sits there, and then it starts pumping out all these bad chemicals that are bad for the surrounding environment.
Well, does it attract cancer and Parkinson's, or does it,
what it
pumps out create?
What it does is it causes a lot of inflammation, and inflammation is associated with the cancer. And it also pumps out chemicals that kind of degrade the surrounding tissue. And one of the things that allows cancer to grow better is having a sick surrounding tissue. So cell senescence is probably arose because it prevents cancer. And early in life it does that, because if you have a cell that starts dividing out of control, but then it reaches some limit and stops, that's good for you. Keeps you getting cancer when you're 20. But that same process, when it happens when you're 60, is no longer so good for you, because now that thing is going to sit there and it's going to ultimately cause you problems. So for a long time, people were arguing about whether this cell senescence really represented aging in miniature or if it was something else. And I think it's something else, but it's something that has a very big impact on aging, because as you start to accumulate these cells in your tissues, in your muscles, in your brain, it causes all kinds of things to go wrong.
And then, so what is it that we do, either recent discoveries that will interrupt or slow down senescence?
Well, the recent discoveries have been people have genetically engineered mice so that they can kill these senescent cells. Like I say, they don't die, they just sit there. In fact, they become resistant to cell death. So they've genetically engineered mice so that they can kill these senescent cells.
Something in their immune system kills.
Well, what they do is they genetically engineer them so that they're susceptible to a certain drug. And they're only the ones that are senescent are susceptible to this drug. So then you feed them the drug and it kills all those cells. So you don't prevent the cells from occurring, but when they occur, you can kill them. And when they do that, they find out there are all kinds of health benefits to it. Now you can't genetically engineer people like that, but what they're hoping is that now they demonstrated that getting rid of those cells is healthy, that they can find drugs that'll do the same thing. And there are all kinds of current studies going on trying to find drugs that do it.
Like I saw your TED talk on metformin.
Yeah. Okay.
And I know that has to deal with that there's a number of existing drugs that are out there that need to be tested in a certain type of in a certain type of study to be used, whether they'll be successful in senescence or they'll be used in other areas of aging.
Right. Yeah. I mean, so this Metformin study is actually, we as a group, I was in a small group of people called a geroscience network, and we've been discussing, is it time to try a human trial for some drug that we think either from human epidemiology or from animal work might slow aging. We decided it was time to quit talking about it and try it. And then the question became, well, what drug are we going to try first? And we chose metformin for two reasons. I was actually in favor of another drug. I was in favor of rapamycin, actually.
Right.
We chose metformin because it's the most commonly used anti-diabetic drug in the world and has been for decades. So there's lots of safety information. The last thing you want is to try some trial like this and have some people die from the drug you gave them. And, humans are incredibly genetically variable, and almost any drug is not going to work for somebody. And you hope it's not going to be toxic, right? But for metformin, there was all this safety issue. And the other part is it's generic. So it doesn't cost much, it's practically free. And that was important because, well, both of these things were important because we wanted to convince the FDA that in principle, they would approve a drug for its, I don't want to say anti-aging, I'll say senescence retarding properties. But they weren't going to do that unless we could demonstrate that it was a safe drug. But also, we didn't want them to suspect we were trying to get rich off this. And by using this drug that's so cheap, they weren't going to suspect that we were just trying to make a buck.
So where is that now?
That is currently being reviewed by the NIH. Probably in the next month or so, we'll get a preliminary decision on whether it's going to be funded. It's a pretty expensive trial by NIH standards. It's about $66 million. But we have a private donor who wishes to remain anonymous who's agreed to put up $35 million of that if the NIH approves it. So I'm hoping by a year from now, this trial will actually be underway.
That's magnificent. That really is. So going back to that sort of recent discussion, you know, there's so much information out there on biohacking, and you know, in terms of citizen scientists going in and taking whatever actions, whether, and I was going to ask you about this, you know, it's called hot shock proteins. I'm trying to understand what that, just in terms of these saunas and hot and cold baths and all this kind of thing. So I mean, there's these massive trend waves that constantly come down. You know, you and I spoke about this when I said I went to a party and this fellow was trying to sell to this group of individuals right there in their home how we could grow your telomeres. And you know, and I'd like to just, you know, ask you, you know, let me roll this back and just find out, do you go into any of that study of what's out there, or has there been any recent understanding of things?
No, I mean, this is one of the unfortunate historical artifacts that aging carries with it, is that there's always been this enormous burden of charlatanry, or just not being that unkind, but just hope. People wanting stuff to be true because we want to think, well, if we only do X and Y, then maybe we won't age. And so there's just one kind of bogus thing that comes up. Now, who knows? Maybe there's something to some of these fads. The trouble is, you'll never know that unless you do some sort of formal scientific test.
But it's been very interesting to see people that are Nobel laureates, supposedly, that are endorsing things. It's like, this is the perfect opportunity for me to introduce armadillo-tears today and say, you know, armadillo-tears have been, it's just been phenomenal, and you know, it has been de-aging me constantly. But I notice in all the there's a constant steady stream of trend waves, and I'd like you to talk about that telomere issue.
Okay, so telomere biology is very, very interesting biology. I think it probably will teach us quite a bit about the biology of cancer. It already has to a certain extent. I don't think it's going to teach us a great deal about the biology of aging. It used to be thought that the cell senescence was really just a consequence of telomere shortening. And so telomeres basically are the caps on the ends of your chromosomes. And every time a cell divides, they get a little bit shorter because DNA can't replicate to the very end. And at some point, they get short enough that your cell senses it as your DNA is damaged. And you have all these surveillance mechanisms in your cell that are cancer protective mechanisms. And if they sense that you have DNA damage in your cell, then they do one of two things. They either kill the cell, the cell commits suicide because there's this program in there, or they put it into this senescence pattern, which means it stops dividing and never can divide again. Now, telomere shortening will do that. So you definitely don't want your telomeres to get too short. But lots of other things will send cells into senescence that are not telomere based. And one of even just the epidemiology, are your telomeres shorter than my telomeres? Do you want, what does this tell you about your biological age? That's about 90% bogus. There's, you'd be better off, you'd have a better predictor of how long you're going to live and how long you're going to stay healthy if you asked 6 people on the sidewalk, guess my age, tell me how old you think I am.
Right.
Than if you got your telomeres.
It's like, it's like when any guy would like to say his telomeres are bigger than their telomeres, but
exactly.
What I'm trying to figure out is when somebody says to you, I have this product that will grow your telomeres, that's like saying, I have this product, grow your telomeres. This is the key to all of aging, and you will live to be 190 years old.
Yeah, run when somebody does. Run as fast as you can.
It's fascinating because, again, like I said, there's these sort of trend waves that come up. And I was going to ask you about rapamycin.
Yeah.
And just in terms of what, because I see that that's part of your studying too. Yeah. Just in terms of what's the state of the state with rapamycin, and explain what it is.
Yeah, so rapamycin is a drug that's been used clinically for decades, but hasn't been used with people that are well. It's been used with people that have various kinds of illnesses. So rapamycin is it's a drug that was isolated from a soil bacteria, and it's very good at a variety of things. One of the things it's really good at is stopping cells from dividing. So one of its main uses is to coat cardiac stents. So they put this in your coronary artery, a stent to sort of prop your artery open. But one of the problems is that cells tend to overgrow that and close it off again. So if they coat it with rapamycin, it tends to prevent that from happening.
Does it do something where if you're getting a transplant that it allows that organ to be? Yeah,
so the other thing is that it's used in transplant biology to help suppress the immune system. Because one of the things that your immune system needs to do to be really effective, it needs to have a lot of cell division. You know, your cells detect something foreign, a new kidney, and they mount this attack on it. Well, to mount that attack, they have to produce a whole lot of new cells. So if you can prevent that from happening, then it will, lessen the chances of rejection. So people thought, mainly in San Antonio, that this was a good idea to try to see if this would also affect aging, because one of the things about rapamycin is that the cellular pathway that it affects is a pathway that responds to food, to nutrients. And we've known for a long time that in rats and mice, if you feed them less, they live longer. So this was kind of a chemical way of making your body think it was being fed less. And certainly the results in mice are absolutely stunning. I mean, the amount of things that it does to improve mouse health is absolutely stunning. And not just, and the other amazing thing is you can give it to a really old mouse. You can give it to a mouse that's the equivalent of about 70, and it still has these remarkable effects. Now, because there's all this clinical history with it, though, we know a lot about side effects in rapamycin. Okay. And it can have some pretty serious side effects. Like I say, it's mainly been given to people who are sick. So it's not entirely clear what will happen when you give it to people who are well. Or if you give it in a different dose, a dose that would be a lower dose, say, than if you were trying to prevent an organ from being rejected. So right now we're sort of in a waiting phase. There's this dog trial that's going on now of rapamycin.
I don't know about that.
Yeah, so there's people in Seattle who have convinced a number of people that their dogs could potentially live longer, healthier lives if they were getting rapamycin. And because we know so much about dogs' health, we can track very, very closely how those dogs are doing. So this Seattle group in this dog aging project has got this group of dogs that they're giving rapamycin to. And they just finished the first phase of this study where they were looking at its effect on heart function, and it looked very good. The animals that were getting it looked like their hearts were declining less rapidly as they got older than the dogs that weren't getting it. But that was a very small kind of preliminary trial. It was mainly to make sure they knew what dose to give, how often to give. There weren't some terrible side effects that nobody had, counted on. So that's where that stands right now.
How long is that going?
Well, that's probably going to take about 5 years. What they're starting it on middle-aged dogs, figuring in 5 years you can go from a middle-aged to an old dog, so they should be able to see something.
See, this is where I was telling you, I don't know if I told you this, but it's a great time to be a mouse. If we could figure out how to become a mouse, boy, we would be in such fantastic.
That's right. We can get rid of mouses, Alzheimer's disease and cancer and all kinds of stuff.
Really not about us aging anymore. It's just how could we use CRISPR or whatever that, is. I wanted to ask you this, and as we move through this, and that is actions that you feel like you have learned that you do and that other people do to create better later years. To sort of have a, it's like, how are you your own lab rat? Right.
So, so people are always asking me this. What do you do?
Yeah.
And I don't. It's interesting. So I once attended a meeting of all of the people in the country, basically, that studied dietary restriction in mice and rats. And so we've all known that this has this remarkable effects on preserving youth and those things for the longest time. And I look around the room, and you'd expect maybe to see all these very, very slender people. That's not what you saw at all. That room looked like America. There were a few people that were like that, but there were also a few people that were very, very obese, and there were everything in between. So researchers don't necessarily, make use of their own knowledge. So I don't do, so here's the only thing that I do. I mean, I do all the stuff your mama told you. I don't smoke, I try to eat a healthy diet. The one thing I do that's kind of out of the ordinary is I do a lot of exercise. I'm kind of an exercise fanatic. Because to me, it's not so much about how long you live, but how well you live. But it turns out that exercise has beneficial impacts in ways that we never ever suspected. So now there's lots of evidence that exercise actually helps preserve your cognitive powers, that it's protective against dementia. Who would have thought that? So that's really, I don't take multivitamins. I don't do any of that stuff. I mean, I don't have anything against it.
You don't take any possum supplements?
No.
Okay.
Nothing.
So, but if you were to talk about a regimen, do you go to the gym and work with weights? Do you run? Do you walk?
I do both. So I do both endurance exercise and resistance exercise. So usually what I do is I will do a bout of resistance exercise and tire the heck out of my upper body, and then I'll go ride the bicycle for 45 minutes and get the cardiac. And then after that, I typically go back and do some more weights. So I do both because we don't really know much about the effect of resistance exercise. And we know a lot about how good cardiovascular exercise is. But it could be that there's these amazing benefits resistance exercise that we don't know very much about because basically humans are crappy experimental animals, and we don't really have good ways of making mice do lift weights. We can put them on a wheel and let them run, but we don't really have good ways to make them lift weights.
But so, have you seen assessments out there, if you look at your own biology and you look at your blood and you realize, oh, I do better if I eat this, or if I do better if I eat this, or obviously this exercise regimen, because when we first talked, you told me that was one of the best ways of taking care of yourself. Well,
it keeps you functional.
Right.
And that's, to me, the most important thing. Like, there's stuff that people that let their muscles go just can't do anymore. Stuff that you might enjoy, carrying your grandkids up the stairs or something like that.
What do you think about those assessments out there that would, like, I'm hearing that they take the raw data from 23andMe and they'll figure out, well, you really ought to be eating pomegranates. I mean,
I think at some point that kind of thing is gonna help.
Right.
Right? Because one of the studies that I did in mice, of all things, but it was not laboratory mice, it was wild mice. I subjected all of these wild mice, and wild mice are genetically variable. They're more like people than laboratory mice, which have been inbred for generations to be genetically identical. And what I found when I did this dietary restriction is I didn't get the normal result, but they all lived longer. I got a result where some of them lived shorter, some of them lived about the same, and some of them, of course, did live longer. And so I've always thought that what that was telling me is that what's good for you isn't necessarily the same thing that's good for me. And I think that ultimately all the, getting this personalized medicine or personalized health, really, I think is going to be, there's going to be something there. Pomegranates might be great for you, might not do a thing for me. On the other hand,
have you seen better measurement tools out there that can identify those specifics?
It's just going to take time because, like I say, humans are crappy experimental animals. So we can't do, if we could take all this group of people and do X and this group of people, we'd figure this out. But you can't do that with people.
So, the last thing I want to talk about is my whole life I've been in the message business and trying to play amateur psychologist to get people to buy something that they obviously don't need, but it would get them the right girlfriend, or it would get them $1 million and that type.
Right.
So in the process of
you're telling me that stuff isn't true now?
Well, I've got a couple special lists that I'll tell it to you. But the thing I wanted to ask you is that in the evolution of making a case for giving money to age science, what seems to be connecting a little more? I mean, if we have that answer, obviously, but in terms of now how you talk to someone that wants to donate to Alzheimer's research, or, I guess I'm trying to I think it's so important because, I see this flock of numbers that are generating that we won't be able to take care of the amount of people that have this disease. And what will help people, on one level, what will help people give money? And then I guess the other level is just telling them to be able to convince people to take care of themselves. But it's really that focus about, what have you learned that's been really getting people to connect with the importance of contributing to age science?
Well, I'm still writing grants to NIH, so I obviously haven't figured out exactly the key message yet. Otherwise, my lab would be so well funded I wouldn't have to do that.
Right.
I think maybe we've been going about it a little bit wrong. I think we were making one mistake early on, and I think now maybe we're making another mistake. The mistake I think we were making early on was in focusing too much on how long you're going to live. And from giving a lot of public talks on this, a lot of people say, I don't want to live that long. I don't want to live to be 150. And I would say, well, if you could live to be 150, but you felt just like you do today, how would that be? Well, that's different. So we sort of shifted from how long you're going to live to how long you can stay healthy. And I think that was probably a better message.
That's an idea about, instead of lifespan, health span.
That's right. Health span, because that's what people care about is health span. Nobody wants to hang on demented, frail, unable to get out of the chair, unable to remember where your food is. Did I eat? That kind of stuff. Nobody wants that. But I think what we've done is now we're trying to sell this to people that could really help by saying, look, you want to stay healthy longer? I'm wondering now if a social message might not be a better message to say, look, do you want to make a difference? There is no better way to make a difference that's going to have social, economic, political impact than to help us figure out how to slow aging. There's nothing that could change society for the better the way that is. So if you really want to contribute, this is the way to do it. And if you happen to get a little health boost out of it, well, that's great too. So I'm thinking maybe that's how our message should be. It's so hard to fight the disease people, because the people that study Alzheimer's disease, they're having so much money thrown at them now. They don't know how to do it. They don't know what to do with it. But if you go up to people that's aging, they suddenly feel this is a little weird. So I'm thinking, well, what if I say, look, we want to help you prevent Alzheimer's disease. But what about if we could also prevent cancer at the same time and then muscle weakness? So what we're really after is to cure Alzheimer's disease, but maybe we can do cancer and muscle weakness at the same time, because that's really what we're talking about. But people don't understand that. They think curing heart disease is great, curing Alzheimer's disease is great. Doing something that cures them both at the same time, that might be a little bit suspect. That's the way I think people feel, because they almost always think, well, is there really anything that we can do about aging? I don't know why they think there's something we can do about Alzheimer's disease, but nothing we can do about aging.
Well, that gives that parallel that you've heard before when we had all these different diseases and suddenly antibiotics took out a huge amount of it.
Yeah, right.
And comparing the idea of helping in aging research to take out a bunch of these things as you get older, rather than just spending this and this and this and this and this.
Yeah, waiting until you get this problem and trying to deal with it, and that problem and trying to deal with it. Yeah.
So I mean that science of communication that I've been looking at in terms of really wanting to get listeners and myself to help different age institutes being able to communicate that better. I'm talking about this whole spectrum of diseases that could be really knocked out if you could, focus the direct dollars in terms of aging. Right.
I do think we're hurt by this reputation for charlatanry that kind of the field can't seem to shake.
Right.
Just because it never goes away. There's always somebody that has the armadillo tears.
Right.
Or clam juice.
That's got my armadillo tears. that's been specially patented, but no, it does go back to you were saying a little bit earlier, if you can make a difference socially, and hearing about impact investing, where someone doesn't want the largest return on their money, they just want their money back, but whatever they're giving, or maybe they don't, it turns into a philanthropy, that they feel like before they go, they've made some turn in humankind.
Right. Yeah. I mean, I think this is something that, for instance, Bill Gates should be interested in.
Right.
Because he clearly wants to make an impact, and he has. I mean, he's made an incredible impact in the world, right? This is a way he could make an impact in first world countries, not just third world countries.
Well, just sort of in terms of wrapping this up, I have to tell you that I think of you as one of those superstars out there, and I so appreciate this today. I really do.
Thank you.
And I find that you are still actively curious. You're still working behind the scenes and diving in, and it's really exciting to see. And having this talk on impossible fossil, as well as for Design Your Age, it helps connect a lot of dots for people that are lost in getting these messages, where it's from, just use this simple cream and your telomeres will, be bigger, and you'll live longer, and your breath you can change your breath any way that you want.
Right. Well, let me give you a little bit of kudos as well, because I think the stuff that you're doing is fantastic, because I think that one of the that people have is they give up. There's nothing I can do. I had some friends whose parents decided at age 75 that they were going to go off to Australia to start a new life. And I thought, that's great. How do you sell that? How do you sell that kind of stuff? And that's the kind of stuff that you're doing, and I think that's fabulous.
Well, it's funny. It's understanding where is that in interruption point, and communicating in a very common sense way that how this will help you, but understanding that there are points of acceptance and there are extreme points of resistance where people will do things to their own detriment. Even though they may have somebody that is a much older mother or father that is, you know, they've already considered their life over at 60, but they have somebody that is 90-year-olds that's moving forward, and you're just going like, I don't get this. But there's that part about it that you just hope that you can encourage those people to see it in new ways and get over old things that they had, which is back to, you know, how advertising and branding sort of breaks things down, and suddenly you're using this dessert as a floor wax. You know, I mean, just
right.
You know, that old Saturday Night Live bit. You know, no, it's a dessert. No, it's a floor wax. You know, just the idea of how you've been able to expand people's mind about what are the uses and how they can see themselves, and how they can see themselves actually. It's something that they actually are doing. And
right.
It's not such a great leap for them. You know, when we talk about the people that are pole vaulting at age 90, everybody's eyes glaze over. I am not going to be pole vaulting.
Right.
But if they see that they can work with a physical trainer twice, and that trainer shows them that they're able to do something that they never thought was they're able to do, that's the place that I want to be able to communicate to people and saying, you see, if you thought of this and you did this, and that goes back to the point about reminding people of the little victories that they had in their life, and that they're still that damn person. They're still that there. But somehow they put this manhole cover over it, and they go like, no, I'm old. I mean, see, I was at a little thing at an Apple store, and this woman, I don't think she was that much older than I was sitting across from me, and she said, well, I'm going to have trouble because I'm old. And I'm going like, you know, you're already dead. And it makes me think about that Monty Python song about I'm not dead yet.
Right.
But anyway, I want to encourage people to, you know, look. I went back over your CV, and I was looking at all your writings, and now knowing this background, it really you know, it's terrific. I'm somewhere out there. I'm planning to do a series of really short films, which are almost like commercials, to talk to people about the irony of this, and using some of your work is something I'd like to be able to engage.
Sure. Okay.
But,
well, it's great to talk to you, Tuck. It's been a long time. You know.
Thanks.
Yeah.
All right. Well,
keep doing the good work. You're doing great stuff. I love it.
Awesome. Thank you so much. Now, let's say that we've ended this podcast.
Okay.
I think it's just terrific to see the sense of humor that Molly's got, and also just, you know, your other daughter. So I mean, that's fantastic to see. It looks like they're having a good time. They are, and the thing I'm proudest of is that neither one of them hesitates to tell me I'm full of shit. Yeah, but that's that part of the Greek myth that's in all of us. We have to kill our parents. Yes, right. No, I think that they're independent thinkers, you know, because dad said it doesn't mean diddly squat. Man, I see these notes after you've noted something and how much they love you. And as a father of 3 daughters, it's one of those things just to see, like, you know, give dad a smack on the ass at the same time give him a hug. You know, I'm glad that you're doing that. Yeah, no, I'm very, I couldn't be prouder or more pleased with my daughters that they still think their dad's okay. You know. That's right. The other thing I was going to say is that, you know, one way or the other, I'll get up. I'll get to that. Good. And one final thing I wanted to tell you is that I have learned, and I'm not asking for commentary here, but I've learned so much about how to actually put together a fantastic cruise or a trip. Oh, I bet. Yeah. Experience. I mean, from soup to nuts, figured out a lot of things. And, you know, and knowing it was not the right point of time for that to be, you know, taken in, I still step back from the experience saying, wow, what I learned. And one thing I'm trying to do, possibly this fall or early in January, is a Design Your Age conference, all right? And I have been doing a beta test on rebranding a person. I'm not a life coach, I'm not a therapist, I'm not a doctor, but I've been bringing in different specialists to help this person, you know, find out where their strengths are and then move forward. And it actually worked on this woman, and I'm still in that process of doing a couple more of those things.
Oh, great.
But it's really, again, breaking down the resistance of how they see themselves. And one area that I really want to explore, which I don't know if you ever come across this, but I've been talking with a bunch of gerontologist psychologists in terms of trying to find out who's edging in that area that's really having success. Because if I had this as a brand at an ad agency, they'd say, let's rebrand aging. I would go to a researcher and say, what are we doing to get people to buy into that? You know, how are they buying that idea? So it's one area that I'm really looking at, because it's an extension of the work that I've been doing in advertising, is what can I do to convince people? In fact, what could I do to get people addicted to taking better care of themselves?
Yeah.
And showing a reward really quicker to them that is kind of a revelation.
Right.
And the final thing I came across, I wanted to tell you about, I'm so excited about, and get you off to do what you do. I found a word which you may have already heard about. And they described a Matisse, and they described Rembrandt in his later years. It's a German word called Alpenschein. Have you heard of this? It's revitalized brilliance. So when Matisse was bedridden and he couldn't paint anymore, and he taped a stick to his hand, and he was trying to draw, and then he started working with cutouts and created this entirely new type of art. He was in this experience of Alpenschein, which I'll send you a note on, but it blew me away that there was this word out there that when you're older, that you could actually walk through a door and create something new, but it was inherently from your own powers.
Right. No, that's a nice word. I like that.
I mean, it was great, but I cannot tell you how much I appreciate this. So,
okay, well, it's been nice, and I'm actually going to see Molly in a few weeks. I've got a conference in Santa Barbara.
Oh, yeah.
And I'm flying her out because it's at this fabulous hotel that she stayed at before, and I haven't seen her for 6 months, and so it's going to be a great opportunity for us to at least connect a little bit.
Well, let me know if you get near Austin, because
I likely will at some point.
Because
I still haven't eaten at Jeffrey's where she works, for goodness sakes.
Right. What a low rent dump that is.
Yeah, that's what I understand. Yeah.
Because I want you to come and we'll share a glass of armadillo tears.
That sounds great, Tuck. All right, great talking to you.
Thank you so much.
We'll see you. Keep it up.
Okay, Doug.
Bye.
Bye-bye.